Hi everyone, welcome to this CIB ECR webinar on smart and sustainable built environment, which is focused on the interplay of economic, social, and environmental sustainability and its implications on definition, design, and delivery of construction projects. I am Sina Moradi, CIB Program Director and a lecturer in project management at the Bartlett School of Sustainable Construction, University College London. Now, I would like to briefly introduce our keynote speakers in this event, Professor Farzad Rahimian from Teesside University in UK, and Dr. Jeremy Gibberd from the Council for Scientific and Industrial Research, CSIR, in South Africa. Without further ado, let's proceed with the first presentation by Dr. Jeremy Gibberd.
Thank you. Can I just confirm, Sina, that you can see my screen?
Yes.
Yes. Okay, great. Okay, thank you for the opportunity. What I thought I would cover, hopefully to complement a little bit what Farzad will cover later, is a kind of broader overview, really around sustainable construction, and how this may happen globally. So I'm going to talk a little bit about the differences in different parts of the world, and also emphasize really targets, techniques, and hopefully that will complement, I think, what Farzad might talk about, which is more the technology, potentially what happens in developed countries, more advanced economies. So really what I'm going to cover, if I can make this carry on. Is start off with a definition. What do we mean when we think about sustainable construction and we think about impacts at a social, economic, and environmental level? So I'm going to just give a picture of that. And then if we want to achieve something, you have to set targets. You need to define exactly what you're trying to achieve, and then drive a whole process to achieving that. So I'm going to talk a little bit about targets and then some of the techniques. What are the different things, the mechanisms you can use to integrate the processes to drive those targets, and then finish off with some references, and hopefully we can have a bit of a discussion at the end. So let's look at a definition of sustainability. And it's useful to go back to the original definition of sustainability or sustainable development that the UN provided us, which talks about the needs of the present and future generations. And this has been criticized quite widely because it's very vague. You know, who are we talking about? What are needs, etc. But if you delve into that a little bit further, there are two quite useful ideas. And the first talks about needs, and it talks about particular part of society, poor people, and you know how, as a society, we need to address urgent needs in that part of the population. It then talks about limitations. It talks about how we organize ourselves as a society, as economies, and what sorts of technology we use, because we've got to achieve this provision of needs within the environment's ability to meet future and current needs. So it's within this envelope that we're going to have to try and achieve development. So those two ideas are very useful because they provide like a social floor where we need to kind of bring everybody up to a reasonable quality of life, and we need to do it within an environmental ceiling. So we need to not breach carbon emission ceilings, water, a whole range of planetary boundaries. So that's a very useful set of ideas. And it is also useful because it helps you think about the context. Um, and two measures of those ceilings and floors that we can use are the ecological footprint and the Human Development Index. So the Human Development Index is a measure of quality of life developed by the UN, and it has a component which is linked to education, one to health, and another to purchasing price parity. And it goes basically from 0 to 1. And there's a kind of generally accepted measure, which is about zero 0.8, which is this line here, which is defined as a reasonable quality of life that everybody should achieve. So you've got that line coming here on the x-axis. If we go to the y-axis, we then look at the ecological footprint, and this is a measure of the amount of space that you require for your living and working patterns. So it's measured in global hectares, and if we take that measure and we divide it over the productive space of the planet, we get to about 1.8 global hectares, and that gives us this line. So we get 1.8 global hectares. And this diagram is very useful because it gives us visually an idea of the sorts of targets, sustainability target that we need to achieve, which is this gray rectangle. So it's above 0.8 on Human Development Index and underneath 1.8 global hectares in terms of ecological footprints. What we can then do is we can plot countries. So if we look in this segment, we have a lot of European countries, North America, some Asian countries, Australia, etc., which have above 0.8, so they've got a good quality of life, reasonable quality of life, but very high ecological footprints. And so any development, the development trajectory in this area, in these countries, and these cities, have to have a focus on reducing the ecological footprint. So they need to move in that direction. We can then look at this segment, and you'll find a lot of African countries, South American, Asian countries, which have very low quality of life, Human Development Index, but are under the 1.8 ecological footprint target that I talked about. So the emphasis here is really kind of driving improved quality of life, improved education, improved health, job creation, etc., so that you move countries and societies within this area in this direction. And this really is important because it shows very clearly why approaches have to be different for different countries. So what happens in the UK, in London, where Sina is, will be very different to a project that I might implement in a developing area of South Africa, So because there are different priorities, there are different issues when it comes to sustainability. They're still the same broad concepts, but we're going to drive and prioritize things differently. Okay, so given that definition, how do we move forward? And there's a very useful set of measures that are provided at a national level that you can use when you look at sustainable construction. So these are the SDGs, and I'm sure a lot of you understand them in a lot of depth. And they provide a useful agreed framework that we can use to drive sustainability into construction. And we can track performance. So we can look at individual countries, etc. And this graph at the bottom, this diagram at the bottom, shows how we're doing on SDG, the SDG 11, which is sustainable cities and communities. And you can see globally we're doing very poorly. There are no countries that are on track to achieve the SDGs. Most have challenges, some have significant challenges, some have major challenges. Most of Africa have major challenges in achieving this SDG. But this is the case across the other SDGs. So you'll find the same for water, for education, for energy. And the reason why I cover this is that we can use construction to address a multitude of SDGs. And I think we need to kind of think about how construction can broadly address urgent local priorities, as well as just aspects like carbon emissions. So let's have a look at targets and techniques. So first of all, if you take the SDGs and you translate them into very specific targets for construction, we can look at a set around the environment. So things like environmental management plans, the type of materials you use, water consumption on site, protecting existing natural environments, energy consumption, pollution, etc. We can then look at the impact that construction has on a site. So are we supporting local economic development? Are we supporting the creation of local jobs, small emerging entrepreneurs, and new business models that are much more efficient? So product as a service models, for instance. And then finally, the social impact. How is construction creating beneficial impacts? Are we using construction to train more people so that we've got local capacity? Are we ensuring that the benefits, the economic benefits of jobs, of procurement, go to people that may be marginalized? What about things like health and safety, stakeholder management, making sure that you work with the local community in defining and developing a particular site? So we can define very clearly many of these different aspects in definable targets, which can then be incorporated into construction documents. So the second bit I'm going to talk about is how we drive those targets and integrate them into the kind of everyday processes that happen on site and all the different stages, from contracting through to handover at the end, when a contractor leaves site and passes this over to a facilities manager. And I'm going to go through each of these in a little bit of detail. Some of this is covered in a number of papers that I've got, so I'll give you those references later. But the first thing that's really important is that you write into your RFP, you write into your tenders, and then into the contracts, the targets you wish to be achieved. And you set them out in a very detailed target way, clear way, and you enable a contractor to cost for them if it's additional cost, and to program for them. So you expect them to integrate these into their construction programs. You provide for a very clear monitoring and recording process. So you define a protocol, again, that can be agreed amongst the key parties, the owner, the contractor, and the professional team, the principal agent. You drive it. So you drive it through penalties and incentives, and make sure that it gets implemented. And you check this at least once a month to ensure that there's the achievement of targets. Provide training. So again, if it's new to the contractor, if it's new to the professional team, make sure there's training so everybody's on the same page. Standards, in countries like South Africa, we're fortunate that they have got some quite clear standards. So there's a South African Bureau of Standards has a skills development standard, the local content standards. So write them into the specifications. And then, if necessary, use an external party to ensure there's rigor in the application. So in the early stages, one of the things that a contractor can do with a professional team and a client is work through designs. So often designs are developed fairly rapidly, sometimes by architects without huge construction knowledge, and a contractor can very usefully work through details. So they can optimize the designs to make it easier to build, less wasteful. They can help ensure that the building and all of its components can not only be put together more easily, but also can be disassembled. So how are for instance, the connections taken? Are they welded? Are they bolted? And a lot of that can be worked through. The same thing with operations and maintenance. So a contractor can work with a facilities manager, with an experienced maintenance officer, to look and understand how the building is going to be maintained and repaired, so that all of that can happen more easily with less waste. The formal part of this is often captured in the idea of a material passport, and an architect design team would incorporate a lot of the kind of key parameters, information about a component in a material passport. So they'll talk about the physical material, they'll talk about how it's put together, how it can be maintained, and that is very useful. So a contractor can make sure that they contribute to that and enable that passport to be available in future for whoever's disassembling the building, for the facilities manager, for repairing, etc. So capturing that information in a material passport is very useful. And then BIM, so building information models, again, enriching it so that it's a useful tool. And this knowledge and information is passed from designer to contractor through to operator, and then end of life strategies. The next thing that a contractor can do is really develop up local capabilities. So it's one thing to develop a building, it's another to run it highly effectively in the long term. And so one of the things that a contractor can do is make sure that they provide training to their employees so that there's good capacity and they become more and more competitive. If they use temporary local employees, provide training. A good way to do this is to work with a technical college so that you provide trainees with access, real life access on site, but also you get all the theory and you get the qualifications that a technical college can provide to you. You can also develop small enterprises. So again, if they're very small enterprises just starting, you can give them small opportunities. They could start with things like transport, security, landscaping, etc., and build this local economic development so that you build that capacity locally, and you have more economic development locally. The same thing with partnerships. You look at partnerships and you'd say, okay, are there things that we can do with other contractors, such as waste clubs, training, and develop joint initiatives to create economic development locally? In South Africa, this is a particularly important issue. There's a history in South Africa from apartheid where many groups were marginalized, but that does carry on, and it carries on globally. And so you have women, you have youth, people with disabilities, people with very low levels of education, unemployed people who have been marginalized. They have been left out of a lot of the economic development that may happen in an area. And one of the things that a construction process over 2 or 3 years can do is draw them in, provide training, provide some economic benefits, and enable those people to become part of the economy so that you have a more inclusive economy that benefits more people. And you can do that through a very proactive approach where you employ and you target marginalized people. You can set targets, you can evaluate those, you can provide additional training. You can also do it through procurement. So if you've got a choice about buying a particular bio-based material or set of poles, you can target more marginalized groups to encourage some of the economic benefits to flow in their direction. And part of this requires a very proactive approach to thinking through economic development locally. So you make sure that you engage with different communities, engage with different groups, and you've got very accessible information, and you make sure that it's easy for people to become part of the construction process, part of the work on site. The next one is much more common. It's about thinking through your site planning so that you make sure that it's easy to store materials safely so that you don't damage those materials. There's an area for recycling, and there's very good health and safety. It's a safe site, etc. So it's thinking through the site layout very carefully early on so that you've got a very safe, sustainable site. It's making sure that that's talked through with all the employees. Anybody who comes on site, there's induction, there's training, there's communication in terms of signage, etc. And then there's accountability. So that's driven by a particular person who's on site and does checks to make sure that sustainable construction targets are achieved. The next one is really around materials. So you may find that an architect has put a lot of effort into specifications around sustainable materials and components, and the contractor sometimes just ignores all of that and just goes and buys the cheapest imported component. So part of what you need to do as a contractor is really think through what were the intentions of those specifications and try and achieve the letter, the idea behind what those specifications stated. Again, if you've got a choice, do you import something from the other side of the country, 800 kilometers of embodied energy and transport impacts, or do you use something locally? So you try and use something locally. Again, if you've got a choice, bio-based materials, so timber materials rather than the steel equivalent, for instance. Can you reuse components? So things like scaffolding, shuttering, how much of that can you reuse so that you minimize waste? Recycle content. So you may have steel from a number of different manufacturers. You choose and specify the maximum recycled content, and then obviously use the more ethical manufacturers, people who are very clear on the environmental impacts, the human health, labor practice impacts, etc. In terms of looking at waste and pollution on site, again, part of this can be addressed at the strategic design stage. So you work through with the design team. How do you optimize designs to minimize waste? So the sizes of tiles, layouts, etc. You may look at prefabricating components, which can be much quicker and much lower waste, reuse components, recycle waste that's generated on site. So again, you might work with a number of contractors or recyclers locally who can come to site and pick up things like ply offcuts and reuse those in other places. Waste clubs, a very similar idea. You avoid hazardous waste, very strict pollution control, and then things like deliveries. So instead of 13 trucks coming to site every day, you look at how that can be scheduled so that you reduce transportation and all of the associated packaging. So instead of all of the wrapping, etc., you make sure that a supplier minimizes a lot of that if it's not necessary on site. So we're now coming towards the end, and this is the stage where you are thinking about handing over your building to a facilities manager, to the owners, to the users. And it's at this stage that is very important to kind of get facilities managers involved and really understand the building, where the cables are, how the controls work, etc., and build this digital file. So it might be a building information model that's transferred across to the facilities manager, but it's also digital as-built drawings and manual. And ideally, it's very accessible and very easy to navigate. So it may be something like an intranet site where you can type in who provided the taps in the lower bathroom, and it'll then show that bit of information, and you can then get the washers changed very easily. So it's about making that information really easy and supporting the operator. Commissioning. So again, there's a rush often that happens towards the end of a construction project, and many things are left very poorly tuned. So you'll find toilets don't work properly, urinals don't work properly. And part of the commissioning process is to make sure you leave a building to work in an optimal way as designed, so that everything is commissioned properly, and you involve the facilities manager in that process so that they really understand how systems work. Come back every every 6 months over the first 2 to 5 years. So that really should be written into contracts. So if there are problems, your contractor will come back and deal with those. They don't just say, not my problem, and leave it for the operator. Maintenance and management manuals and a building user guide. So again, the interface, not just for the facilities manager, but also for building users. So making sure the building shares data about the building. You know, what was the energy generated yesterday from the sun? How much water did you consume in the last week? And sharing that information with users. So to finish off on, just to give you, this is an article. I'll give you some references right at the end, but some of these targets have been developed in quite a lot of detail in South Africa. So there's a particular article that shows how this is incorporated, particularly in government projects. And the same thing for labor intensity. There's quite a lot of manuals and targets that I can share if anyone's interested. And these are some of the references. And yeah, anyone's welcome to contact me if they need detail. So thank you. That's me.
Thank you very much, dear Jeremy, for your very interesting presentation. Now let's continue with the second presentation by Professor Farzad Rahimian.
Thank you. I'm just not frequent user of Zoom. I'm looking for share if I found it.
All right, I think I've stopped. Yeah, there we go.
Okay. Yes. Thank you so much again. Can you see my screen?
We can see the screen, but no presentation on it.
No presentation. What about now?
Now we can see, yes. You just need to put it on the presentation mode.
It is on presentation mode on my machine, not on...
It is on the presenter mode, so if you have any presentation note, we can also see them. Okay,
let me just stop it and do it. Probably I'm sharing a wrong screen. Now I have to find it and stop sharing. As I said, I'm not very good at Zoom. So screen one share. So do you see my PowerPoint now?
Yes, now we can see it.
Okay, and you should see my presentation now.
Yeah, perfect.
Okay, yeah. Okay, and I don't know how to minimize this thing, but never mind. So yeah, good morning everyone, and thank you, Jeremy, for setting up the flow. I'll just take it from there, continue some of the discussions. I'm Farzad Rahimian. I'm the Professor of Digital Engineering and Manufacturing at Teesside University, and I lead a center called Center for Sustainable Engineering. I will talk about it. But most important thing to tell is I'm the editor-in-chief for Smart and Sustainable Built Environment, a journal which came out of this working commission and is now one of the leading journals in sustainability in the world. And throughout this presentation, I will have some QR codes there and there, and you can just easily scan them. I don't know if Sina will be distributing the presentations later on. You can just get these QR codes from the presentation as well. And there's a QR code to the journal. Before I proceed, just one announcement about the CIB conference this year is going to be in soon in Lille, France. And as you can see, Jeremy and I are the honorary chairs of the conference. We have a very astonishing set of keynote speakers. I've never been myself in my career in a conference having this level of magnitude of names and profiles of keynote speakers under one roof. This is a very fortunate that we have these world-leading scholars as our speakers. The conference will be in 3rd to 5th of November. The abstract submission has passed the deadline, but we still accept full papers. So feel free to submit your paper and join us in November. So coming back to the conversation that Jeremy kindly started about the technologies that can support sustainability. Let's just go back to the government strategy about the net zero UK by 2050, which has a lot of pillars, and there are several reports already published. And just as part of this initiative at Teesside University, we've made a lot of significant investments in some infrastructures for supporting this agenda, one of which is our new successful investment in the Net Zero Innovation Center, which was 16.4 million in the phase one, and it's going to be up to 40 million over 3 phases. And this is in collaboration with Tees Valley Combined Authority, Durham University, and Teesside. And the agenda is to support this government strategy. I'm just putting some umbrellas on all these conversations that Jeremy mentioned. The credit of this figure is to the government strategy 2050. But if you look at this circle, what you can see all these enabling technologies, from biomass to demand side response to hydrogen appliance, etc. And in support of some industries like power, transportation, heat and buildings, hydrogen industry, CCU, carbon capture and storage, etc. But what happens here? The most important thing is we are targeting to make impact on people's lives and the environment. That's like when we talk about all these technologies, we should not remember that we are not serving the technologies, we're serving the real impact on people's lives, which is a better life, as Jeremy mentioned, better life for people and better planet to live in future. So coming back to what we do, these are the research groups that we have at our center, and we focus on several technologies, one of which is the digital construction that I used to lead it. Now I'm co-leading it with Professor Sergio Rodriguez. And we have some interesting projects in our hosted by our center, and one of them is our Reconstruct project. I'm just trying to see if it works to play, otherwise I will have to do something else. Yes, it played.
Among the most environmentally damaging human activities are steel extraction and cement manufacturing. The construction industry is a propulsor for both sectors and responsible for over 30% of the extraction of natural resources, 25% of solid waste generated, and 40% of GHG emissions. But what if we could use more sustainable cement? What if we could use technology to recover waste and transform it into construction materials? 16 institutions are working together for the EU-funded project Reconstruct. They are focused on developing low-carbon alternatives to ordinary cement and incorporating waste into reusable manufacturing components. They will demonstrate this in 2 case studies, in Barcelona and Brussels. The use of digital tools will support all the building phases, reflecting the circularity in the construction industry. Reconstruct will transform the way we think about the industry. It will reconstruct it.
I like this video because it just covers in 30 seconds a lot of topics that I was going to talk about. And this was an introduction to our Reconstruct European project, which is 7.8 million European Commission funded project. Teesside University has around 800,000 share in this project. We lead 2 main activities in this project, one of which is the 7D BIM, which is the sustainability dimension of BIM, and that's where we look at the ontologies in relationship to waste management and LCA, and also we lead the dimension of social innovation for these activities. What should be really not forgotten when we're looking at technology adoption in industry? This is the metaphor of the iceberg. We always look at the visible tip of the iceberg, which is very small and negligible in comparison to what is hidden down there. And this negligible part is the technology, and mainly our problem is with the process and people, and that's the main reason our industry always lags behind other industries, because otherwise we would use the same technologies, to be fair, in comparison to other industries like automotive industry or aerospace. But what we don't have is that skill of the people, as Jeremy vastly mentioned about it, and the processes in place to adopt these technologies. And that's mainly one of the most important things that Reconstruct project is doing with our leadership, with social innovation, to make sure that people and stakeholders are buying into all these initiatives. When you're talking about industry symbiosis, when you're talking about the groups for waste valorization and other technologies, from image processing for detection of waste to digital product passports, etc. This is about co-creation of these technologies with those stakeholders to make them use it. Another sample that I would like to share with you today is a project that we started with a company in very north of Scotland. And this company had a huge capacity for rescaling themselves. They could triple their production without any penny investment, but the problem of a company like this is the procurement of new projects because of the distance between them and their clients. We started this project in 2017, and this has been like an unfolding success story. We keep winning grants, and recently we received a grant from UKRI for another 7 years Futures Leaders Fellowship, which is a huge success for this project, and we just taking it to another dimension. And throughout this project, what we're doing is to embed all these digital technologies into the production of kit homes, which making the process more transparent for co-creation, making smart technologies, embedding smart technologies in the kits for making it more supportive for elderlies and people with special needs, and also using this as the design calibrator to facilitate design design sessions and co-creation with the future clients. We received several awards for this project, one of which was the Innovation of the Year award from Scottish Government. Another one was the Building Smart Internationals Award in Tokyo in 2018. And as I said, this project is unfolding, and hopefully the real impact will come after 7 years when we finish this new WellBe project, which is about, as I said, embedding these smart technologies into the products and making it more user-friendly for elderly people and people with special needs. What also we are, another dimension we are adding, as Jeremy started the conversation about, is the digital product passports and AI for optimization of the production planning and control in the factory. And what happens is, if you look at the factory, they receive these timber and aluminum profiles in different lengths, and they have some production control measure for making use of these offcuts, like it's kind of a symbiosis within the factory. One profile, one length goes to one production line, then when it is cut, it gets a barcode, and with that barcode it moves to another production line until it comes to a smallest length that is not useful. But with the use of large language models and NLP, we are upscaling their barcoding system to optimize this process and make sure that those lengths, especially when you're looking at aluminum, those lengths are as small as possible, and we are minimizing the waste. So all these technologies are serving in the interface level, also very back end, which is the factory production. I just passed these. Coming back to blockchain technology again, Jeremy mentioned digital product passports. To build up a little bit more on this technology, there is a lot to say about blockchain, but I want to emphasize on the only the crux of this, and just say that this technology is for transparency and for making sure that people are saving all the processes within the blocks, which are locked and secure, and they are tamper-proof, and this remains there for future to tell the story. These two pictures, I always do a lot of conversation about these, but these are very simple cases of the largest scam events in the whole history of humanity. This beautiful lady managed to steal $4 billion from people with a cryptocurrency network called OneCoin that didn't have a blockchain, and it was built on a centralized database. And as easy as that, she stole $4 billion and disappeared. And this painting was claimed at some point that was painted by Leonardo da Vinci, then sold $980 million, then was happened to be known as painted by apprentice of Leonardo, then the price dropped to 400,000. And this is about how vulnerable is our community about fraud and about disparity. But what happens is if we have a process onward that everything is stored in tamper-proof block, then things will be not in the similar way that I mentioned. This is a story that we worked with a company called Yonder Data Centers, and we use this technology coupled with digital twins for commissioning of data centers that they make and they sell or rent it to Amazon, Facebook, Google. And this, the technology of blockchain and the visualization of their assets on digital twin saves them millions in terms of making sure that the waste is minimized and the transactions are approved and verified in no time. Moving on, talking about these technologies and how they can contribute to saving resources. We worked on a project in collaboration with a company called Nycander in Tees Valley, and this is a digital twin for Stockholm bypass, which is the world's second longest city tunnel. And with this project, we put the entire tunnel in a digital twin, and all these assets from the fans to sprinklers to cameras to ducts, everything are embedded in the digital twin with all these functionalities and features. And this is where, when you have a grasp of a large mega project like this, then you can do multimodal analysis on everything. And when I say everything, that could be traffic management using the surrogate model of coming from satellite imagery, from historic traffic data, from information coming from computer vision, from the cameras, etc. Then you can make tailored decisions about traffic. Even the traffic lights in this, the traffic lights and traffic signs, speed limits are controlled by the system. Also, you can use these information for predictive maintenance of the assets in the tunnel. Another byproduct of a project like this, when you have all this information on an asset, digital asset, it is very easy to use it in different ways. This is how we use the similar technology in the city of Dublin and Melbourne for bus tracking and prioritizing. What happens is that the buses run different times of the day, different times of the year. Due to some repeating circumstances, we have some delays in the traffic. And there are some criteria. Buses cannot be late for more than some certain minutes. The tolerance depends on the time and also the place. But for sure, buses cannot be early. So how to manage this? It is a big story, but when you have right data in hand, you can predict, you can tune it with the information coming from the GPS, from the traffic lights, from the cameras. But most importantly is that you can make interventions, like for prioritizing. If you feel that this important bus is going to be late, you can just stop the traffic light for the other traffic and prioritize this bus, let it pass, then it goes. And this is the story that helped us in making impact on saving a lot of carbon footprint in those cities and in other activities. I passed this project and moved to this one. Another use of these technologies is to use them for extracting the heritage DNA of heritage sites. Again, one of the main reasons of our environmental pollution for construction is the demolition. And demolition is on the a lot of projects. We usually find this is easiest way to demolish a building rather than even thinking of refurbishing it. And when it comes to sites, the waste is huge. One of the most important reasons that we tend to demolish is that we don't have information. And in this project, we try to use some information for capturing the heritage DNA and trying to use it in our discrimination tools for making decisions in heritage site management. Again, no time to go too much in depth, but let's pass this. But last but not the least, one of the most interesting projects that I've been involved is the use of this kind of immersive technologies for training but training in a safer environment. One of the first projects in the world working on construction site simulator for training was our project that we did it as part of a European project called ManuBuild, and started 2006 and ended 2010. But this is a new version of that. We extended this, and we are using the immersive technologies and game engines for simulating these switch gears for very high voltage electrical applications, and using it for a company, very famous company called Faraday, that they provide training to all these big names in the world, from Cisco, Siemens, a lot of other General Electrics. And but when you're looking at this kind of assets, they are very expensive to acquire. Even if you want to ship them from here to Singapore, you're talking about a lot of carbon footprint. But with this application, we managed to create the curriculum in the safe virtual environment, and trainees could just log in within that forum, and they play with these switch gears as if they are working with the real assets, and they make the decisions. The scenarios are embedded, and finally, if they learn enough experience, they can pass, and they can just only fly over to UK for the final testing and getting certified in the switchgear that they are working on. So to wrap up, the technologies are a lot, but what is important for us is to look at it and see how we can manage to put these technologies in line with right processes, and upskilling the workers and staff, changing mind for managers, and changing mind for workers and end users, to make sure that these technologies make impact on our environment and people's lives in a positive way. I stop here, and this is a QR code for my LinkedIn account. I will be happy to continue this discourse to the next stage should you have any questions and comments in the future. Thank you so much.
Thank you very much, dear Farzad, for your very interesting presentation. Now we have about 5 minutes time to take the questions from our participants. So please feel free to ask your questions from our keynote speakers. Okay, while we wait for the questions, Jeremy, do you have any comment on Farzad's presentation?
I have a question, because I think, technology is very interesting. And if you look at sustainability and technology, it tends to be adopted much quicker by the professional team, so architects, engineers, etc., and also quite fast by the facilities managers, and people operating, especially big portfolios. And what I was interested in was the kind of smaller contractors, the kind of day-to-day, the ones that might build housing, not at a huge scale, and just what the adoption rate of adoption was, because I think inevitably they will start adopting it, but whether there was a big lag with particularly the smaller contractors, because that's what we find here. We find some contractors will struggle even with really basic technologies. And I was wondering in the UK how fast that was being adopted, and whether there was a program maybe by government to try and speed that up.
No, Jeremy, that's a very spot-on comment and question. And when we're talking about this and social innovation and working with clusters, the biggest issue for all these technologies is the SMEs, especially the smaller companies, and that's for many reasons. One of them is the rigid business model. They imagine a van just moving around doing some certain job morning to evening, 7 days a week. So coming and asking them to change entire thing, even they don't have time to stop for 5 seconds. So that's the biggest issue. The other one is their ability to invest in capital and not sure of the return of investment. And that is from our reconstruct co-creation sessions for not for UK, for all these countries, especially Brussels and Barcelona cluster that we are engaged with, several companies. That cannot happen without some incentives from governments, and obviously this is the stick part is the regulations, similar to what UK government mandated in 2014, started and rigided in 2016. All the companies were frightened, and in that time I was working in University of Central Lancashire, and there's Lancashire Best Practice Club. Every single Tuesday we had BIM breakfast, and people coming and were just so frightened. What's going to happen?
Yeah.
How can we cope? But eventually that made a huge impact. So sometimes a big force from government or sometimes investments. What I like about UK, we have this UKRI funding called Place-Based Impact Accelerator. From time to time, they choose topics and they make investment, large amount of investment. When you each round maybe 40-60 million pounds, and that goes for particular region for focusing on something to make an impact. Like we now have one approved for our it's called investment zone. One is in Manchester, one is in Tees Valley, and that's 180 million for Tees Valley over 20 years. That's investment in immersive technologies. So that's how the money comes to the local authority and the university like Teesside, and it's just slowly injected into these local companies for making them build their capital and also helping them upskill their workers. For example, our previous ERDF funded IDTC, what we did, we asked the companies, if you dream of any equipment that you're not sure of, that tell us, we buy it, you come and play with it. If you like it, go and buy it for yourself. If you don't, then you don't buy it. So because we had that 13 million pounds here, So with that, a lot of software, a lot of hardware we purchased, they experienced it, and we had these preloaded technicians here to help them to learn how to. Once they tried it, in most of the cases, they went and bought it. And that's how this kind of initiatives with some investment and some forces from government can derive this. But as you said, the problem is at the bottom of that pyramid, and we have to find a way to push it.
Farzad, sorry, there is a question in chat for you. If you can read, or I can read for you if you want.
Let me. Thank you. Thank you, Dr. Farzad, for your insightful presentation and the fascinating topic you have explored. If I may, my question is digital twin application when integrating with blockchain. How do you address the challenge of maintaining real-time performance given the scalability and legacy limitation of blockchain? Yeah, very, very good question. I submitted a paper in collaboration with the team in Cambridge from the Future Roads project. And that paper is all about reducing the frame rate and the calculation size when you look working with large amount of data. As always, when you look at scalability in game engines like Unity and Unreal, they can go as far as you want, provided that you have that computational power in place. But the question is, can we just put whatever we want? Like imagine Minecraft. What's the unique innovation behind this multi-billion company is that they decided, okay, let's make things out of block. And that out of block gave them that power that they can scale up to a very, very multi-million user capacity, even billion, and they kind of capture the whole world. So in all these technologies, the important part is to make sure that how to reduce the size. But when we're talking about blockchain with digital twin, we don't have to put all these digital assets in a blockchain. It's important that we have some representations and we put those representations in the blockchain, and they can be linked to the digital asset in the digital twin. And those blockchains, and that's how exactly the idea of digital product passports work. We are just talking about some identifications and some classification, and that's where the ontologies come in, that what is going to be in that digital product passport. Once it's there, that could be part of your IFC schema or digital twin schema, then we have no problem with scalability. But if we ever try to put a 3D model in blockchain, it will collapse in the first step. I published quite a lot of publications in blockchain. We have this book, Blockchain of Things, with Faris El-Gayesh. Also, we published quite a lot of papers in automation in construction. If you just simply search my name on Science Direct, you will see 4 or 5 papers on blockchain and the book with the Springer nature. But I'm also happy to have another conversation another time after September, please. Happy to have a look at if you have any running project.
Thank you very much, dear Farzad, for your response. Our time is already up. So I would like to thank all our participants and also our keynote speakers for this great session, and wish you all the best. Thank you very much. Take care.
Good. Okay. Thank you, everyone.
Thank you.